My name is Christine G, and I'm going to be going over this problem number 10 in Module 6, and it's a simple linear regression problem. So the first thing we're going to look at is that the data set tells us the number of days absent, which is X, and the final exam score, Y. And this is for a sample of college students in a gen ed course at a large state university. So we're given the absent count and final exam score. So we're going to look at that. We're not going to use this other table because we're going to use StatCrunch to do this problem and make our lives much easier. So here, the first question asks us to find the least squares regression line, treating the number of absences as the explanatory variable and the final exam score as the response variable. And it makes sense to me, thinking about this, if you're absent more, your test score on your exam would tend to be lower. So let's take a look at that. And here we see if you're absent 0 times, you're getting higher score than if you're absent 1 or 2 times or any of the others. So it looks like as the number of absences go up, the trend is that the final exam score tends to go down. So that is a negative trend or pattern that we're seeing there. So let's go ahead and open this in StatCrunch, and then we're going to compute the, let's see, we'll go into here and regression and compute the simple linear regression. So our X variable is the number of absences, and that our Y variable is the final exam score. Now, one thing that we're going to have to do later in this problem is figure out about the residuals. So I'm just going to check that here for now so we don't have to do it later. And then I'm going to compute, and we can take a look here, and we see that our equation's right up here for us very nicely, and this negative 2.84, instead of writing number of absences, we'd just write X, because it'd be negative 2.84 times X. So we'd substitute that into this equation, and then the 89.12 we'd put right here. And instead of writing final exam score, we'd write Y or Y hat for the regression. So this looks good. And what I want to point out here is that we have a graph that we can review, and you'll see the trend is going down. As we increase the number of absences, the final exam score decreases. And we know that on average that goes down by 2.84 points for every day that a student's absent. So if they're absent 2 times, it would go down 2 times negative 2.84 points. So let's go ahead and take a look at these other questions. And so it says, interpret the slope and y-intercept if appropriate, and we have to choose the correct answer. So the first one asks, the average final exam score of students who miss a class is some amount. It is not appropriate to interpret the slope. Okay, our slope is right here, and we've been interpreting it. We've been looking at that. So this one I would not select. And then this next one, for every additional absence, a student's final exam score drops 2.84 points on average. And that's true. So as I just mentioned earlier, if they go, if they're absent 1 time, it goes down by negative 2.84, and 2 times that would double. So that looks correct so far. And then the average final exam score of students who miss a class, who do not miss a class, is 89.12. And that's correct, because if we put 0 in for X, 0 times negative 2.84 is 0 plus 89.12 is 89.12. So that looks right. Let's just see why C and D are incorrect. Here, C says it is not appropriate to interpret the y-intercept. That's not the case. And then we just did it up here. And then it is not appropriate to interpret the slope or the y-intercept. That's false. We interpreted both. So good. And then we want to predict the final exam score for a student who misses 5 class periods. So what we want to do is put in, let me see, I have a, we're going to use the regression equation, and let me see if I can find, I have a, nope, I can't find the document I had. So I tried to write it out on a document, but we can just do it here. So if a student's absent 5 times, so we can even look at the equation up above right here. So we'd put in 5, we'd substitute 5 in for x, so 5 times the negative 2.84, and then we would combine that with 89.12, and our answer would be 74.92. That's the average, that's the prediction for a student who misses 5 class periods. So it's like the average. So, and then we're asked to compute the residual. So in StatCrunch, I have this column for the residuals. And so if they're absent 5 times, then it would be negative 0.22. Now, another way that we can compute that would be to look at the original amount of times that they were absent, which is 74.7, and we'd see our prediction is 74.92, and so that this is below by negative 0.22. So right here, this next question would be, is the final exam score above or below for this number of absences? And that would be below. So we're just comparing the prediction for what the actual amount was for that particular student's score for 5 absences. Now here we already have the graph that StatCrunch did for us, and we'll notice the pattern, and we have like what's called a fitted line, and it's going downhill, and so we know that from the slope being a negative number as well. And so this looks good, this doesn't look correct, and then our slope is negative. This is not a negative slope, so this would be a slope of 0. It's not going up and it's not going down. And then this, we don't this is just a fitted line, and we don't do this like go up and down when we have a fitted line. So it's linear. It doesn't go up and down. It just goes in one direction. And then the last question, would it be reasonable to use the least squares regression line to predict the final exam score of a student who has missed 15 class periods? Why or why not? Well, because we're just looking, our data set is only from 9 days. So if we click here, we only have 9 absences total. So we don't have information that's outside of our range. So, or the scope, it's outside of the scope of the model, 15 absences. So that would be no. So that is it. So please let me know if you have any questions. Feel free to reach out anytime to me. And thanks so much for watching. Have a